Dear students, in this video we'll continue the classes and methods remaining topics. In our previous video we have discussed on two methods, str and init. Init makes it easier to initiate or instantiate the objects. Str overrides the default behavior of the Python built-in str function. And we discussed few problems on it and the different ways of passing parameters, all those things we have discussed. So in the present class we will discuss operator overloading. Some languages make it possible to change the definition of the built-in operators when they are applied to user-defined types. This feature is called operator overloading. So for example, to override the addition operator plus, we provide a method named add. So in this example, we are overriding the operator plus by writing a method add. How we are writing that? Already we know all these things. We create a point class. We know how init works. We discussed few problems on it. Now this str also you know when we want to print the things, it overrides the str or it overrides even the print. Now the very important thing is this, how this method overrides the operation which has been done with an plus operator, right? We are receiving two parameters here. So what are these two parameters are? First parameter is the first object what we are going to pass it, and the second parameter is the second object which we are going to pass. So left of this plus operator is considered as in self. The right of this plus operator will be taken it as an other. So since these are point objects, we are extracting each attribute of that point, the x coordinate and the y coordinate separately and adding. So and we are returning this result back to the calling methods, right? How we are invoking? Just by writing an plus operator. Whenever I rewrite this plus operator, by default it invokes this method and it performs this operation and we get back this result in the new object which it's been creating, that is P3. So here when we create an object, so by writing the name of the class and we are passing the values 3, 4. So it has been initialized for x and y value of this P1 object. So here 5 and 7 will be assigned for this P2. So we are adding 3 plus 5 and we are going to get 8. 7 plus or 4 plus 7, that is 11. We are going to get it for y coordinate of the point P3. So we are printing P3, it invokes this and we get that result 8, 11. So this expression P1 plus P2 is equivalent to this P1 dot add of P2. So even if you invoke like this, it invokes the same method, or with this operator, it invokes the same method. Sorry, execute this. Yes, then you execute it. This is what the result you got it. So we'll do the changes because I don't want to add method or want and sub. I'll just rename this add to and sub. The operation what has been done on this, we'll just correct these changes to do the subtraction, and the parameter what we are passing this as the things. So it will work like subtracting these two. So what was the result we are going to get here now? 3 minus 5, 4 minus 7. That's what the result. So we get minus 2, minus 3. So this double underscore add double underscore is to replace the operator or to override the operation of the plus. Double underscore sub double underscore is the method to override the operation of minus. What if it is multiplication? Yes, we can do it. So we have written here So for the multiplication, MUL. But very important thing on this multiplication, so you are not just multiplying the x and y coordinate and we are passing it back. Mul, it invokes the, whenever we write a star operator, it invokes the method mul, which assumes that the other operand is also a point. Because in the mul there are two things, one is mul and the other one is r-mul. So when we are writing a star operator, it checks what is its left operand. If the left operand is a point, then it invokes mul by assuming the other operand is also a point. By chance, if you write the first operand is point and the second operand is in scalar, it results with an error. So we should be very careful when you are overriding the for the multiplication operator. It computes the dot product of the two. It computes the dot product of the two points, and then you are going to get the result in the scalar. That is how this mul will work with. Here it's been written with r-mul as well. So first we can just do it, changes here only, and then we'll execute this, how this works. Okay, let us not waste the time. We'll make use of this only. Here it works like a dot product, multiply x coordinate of both, then add this with the y coordinate of both of this. In the r-mul, it just multiply the things and we are going to get back. But the parameter here are different. Here is an example. So we create two point objects, P1 into P2. When we are invoking this, it invokes the mul. We get the result in the scalar form. But the second example is P3 is equal to 2 into P2. It just checks what is its left operand is. If the left operand is in scalar, then it invokes r-mul. The self will receive this P2 as an object here, as an argument. This 2 will be assigned to this other. So self dot x into other, comma, self dot y into other. You just multiply this scalar value to the both the coordinates of the point object, and then it return back that as a result. Either you write this or you just write print 2 into P2, it works similar to it. So first let us execute this and then we'll see how this works here. So this is what the result. So 3 into 5 plus 4 into 7 is the result. You got it here, 43. 2 into, this is P2, 2 into 5, comma, 2 into 7, that is the result what you get it for this r-mul. This example demonstrates some of the difficulties of object-oriented programming. Sometimes it is hard to find out which method is invoking with the operator as well. The next, suppose if you are trying to print like this, 2 into P2, it works fine. Why not P2 into 2? Anyhow, two objects, the self, anyhow, it's receiving the point and the second is the things. Just by seeing this definition, if you get confused and you try to pass this, it keeps searching that there is no attributes associated with the 2 because 2 is an int. So int object has no attribute. This is what error you are going to get when you are trying to work with P2 star 2. The next topic is polymorphism. Most of the methods we have written only work for a specific type. When you create a new object, you write methods that operate on that type. But there are certain operations that you want to apply to many types, such as arithmetic operations in the previous sections what we have discussed. So if you want to apply it for the many, like let that plus operator work on the point and also a normal integer and a float, all those things if you want to work it, how you can make it done. So if you want to support for that, for example, like you see here, mult add, this is the function, I'll write it. So in this, let x, y, z are the three parameters it receives. So let it multiply x and y and add the result. For that result, add z. So if it is a normal thing, I'll just write this 3 to 10 is the parameter I'm passing. Let 3 into 2 plus 10, that is what the result I'm expecting. How this can be worked here? It can be worked very simple. Okay, you can understand this very easily. What if I want to do the same operation with the pointers or a mixed type of things? How it can work? So if I create two pointers here, P1 and P2, point objects, and I'll pass 2, P1, P2. How this works? So 2 will be received in X and P1. So multiplication 2 into P1. So it has to do the multiplication, means an armal, then you get a point now, correct? So that has to be added with P2. So then you require an add method. With that it can work it in the second one. P1, P2, 1. Let it multiply points P1 and P2. So this addition can be done with add method, and then this multiplication, right? This multiplication will be done with this mul. So you're going to get a scalar value here. That scalar value will be added with 1. So if I want to do all this, then we make use of all these operator overriding. So instead of this plus operator, let it use this add instead of the star if both are points. Basically, the left of the star is a point, then it denotes this. The left of the star is a scalar, then it denotes this. So we just combine all these things and we are executing both the things in it, just by passing a normal values and by passing a point. Objects of type point. This is what the results we are going to get. The function like this that can take a different types of arguments is called a polymorphism. So we'll discuss the next example. Consider the method front and back, which prints a list twice, forward and backward. Here we are creating a list and we are passing this list to as an argument for the definition what we have written here. So we receive the list and we import the library of copy. We are copying the contents of the front to the variable back, and we are invoking a method reverse. So it reverses the contents. We are just printing both front and back in the form, we are converting it into a string and concatenating so that we can able to print it. So we execute this and we execute this. So we get the list in the front 1, 2, 3, 4 and in the reverse 4, 3, 2, 1. This looks quite simple. It can be done easily. But what if these things can work on a point object? So how can we done that? So we already know the point, even the objects will accept the copy method, and printing we already know str can override this effect. But the very important thing is we need to know how to implement this reverse method. So in order to implement the reverse method, we use this tuple swapping. So receive the object, exchange the value of x and y coordinate. So this can be done with the reverse. So now we include all those things what we have done so far, initialization, reverse and str, and we invoke the function front and back, and we are creating the point object by passing 3 and 4 as a value for this. We'll just make the changes. Instead of 3, 4, we'll make it 13 and 24 are the point objects which we are initializing, and we are calling the function front and back by passing this point. So when we receive that point here, so we import the library and call the method or use this function to copy, and we invoke this method reverse. So when we invoke this method reverse, it reversed, and we are using this print, so it invokes this method str. We get the string back there. Okay, we already executed this. We'll execute this and get to know what's the results. Okay, with this, the fourth module has been completed. In the next video, we'll start with the fifth module. Thank you.